we are having here Dickmann reaction. Okay, so for Dickmann reaction, students remember that this reaction is cyclization reaction. Second point, this reaction is intramolecular reaction, means only single molecule will take part in the reaction. And third point, you have to remember this reaction will be given by the compound which is having the diester functional group. Okay, means any organic compound which are having two ester functional group, such type of reaction will show the Dickmann reaction. So for Dickmann reaction, you have to remember 3 points. First point, it is intramolecular reaction, means only single compound will react. Second, uh, this is a cyclization reaction, means whatever open structure you are having, it will get cyclized to form the cyclic compound. And third point, you have to remember ester compound which are having the diester functional group will give this type of reaction. Okay, so Dickmann reaction is the intramolecular chemical reaction of diesters in presence of base, and it will give the beta keto esters. Okay, so when you are performing the Dickmann reaction, whatever product you will get, the product is known as beta keto ester. So see here, I have given the general reaction. So you can see the reaction, you are having the ester compound which is having the two ester functional group. Okay, and remember that whatever reaction you are studying, it should be having the enolizable carbonyl compound. Then only you will be having the all the enols and enolates type of reaction. Okay, so again in this case, you can see that this is the alpha carbon and this alpha carbon is having the alpha hydrogen. So condition for the Dickmann reaction, it should be having the diester functional group. So you can see the structure, it is having the diester functional group. Okay, and it should be having the alpha hydrogen. So as it is having the alpha carbon, so this will be having the alpha hydrogen. Okay, so now this Dickmann reaction, when you are carrying this reaction in presence of base and acid, you will get the beta keto ester. You will get the beta keto ester compound. So what is beta keto ester? So this is the ester functional group you are having, and you know that whatever carbon you are having the ester functional group, that will be counted when you are numbering. The ester carbon should be counted. So this is your first carbon, means alpha carbon. Then you are having the this beta carbon, and to the beta carbon you are having the carbonyl functional group. So this is beta keto ester compound. Okay, now here I have given the mechanism. So you can see the mechanism, you are having the compound which is having two ester functional group. Okay, now this compound is having the alpha hydrogen. You can see that here you are having the alpha hydrogen at alpha carbon. Okay, now when you are adding the alkoxide, that is base, it will abstract the alpha proton, and it will form the alcohol. And you will get this enolate structure. Okay, when you are treating the ester with base, and here base you are using as a alkoxide, you cannot use the strong base because ester will get hydrolyzed into the acid and alcohol. So we have to use the alkoxide for the enol and enolate formation. So here we have used the alkoxide, that is OR minus. So this OR minus will take the alpha proton from the diester component, and it will form the enolate ion. Okay, now this enolate ion, you can see that oxygen is having the negative charge, so this negative charge will move, and whatever alkene structure we have formed because of the abstraction of proton. Now, when negative charge is moving, the carbon will be having the pi bond. So that is not possible. So pi bond will migrate. Now you are having the another component, this ester function group. So in that you can see that you are having the carbonyl compound, and you know that oxygen is more electronegative, so it will pull the electron towards itself, and oxygen will be having the negative charge, and this carbonyl carbon will be having the positive charge. Okay, partial positive charge, we can say that it will be having a partial positive charge because of the electronegativity difference between carbon and oxygen. Oxygen having the more electronegativity, so it will pull the electrons towards itself. So oxygen will be having the partial negative charge and carbon will be having the partial negative charge. So now, as alkene structure will try to give its pi electron, so it will get the carbon center which is electron deficient. So this pi bond will form the bond with this carbonyl carbon, and when this is forming the bond with this carbonyl carbon, you will get this cyclized structure. You will get this cyclized structure. Okay. Now once you have formed this cyclized structure, now you can see that oxygen is having the negative charge. So now negative charge will try to come its original position. So when it is coming to its original position, so around this carbon you will be having the 5 bonds. So that is not possible. So in that case, one group has to depart. So now you are having the OR group to depart, or you are having the these alkyl group to depart. But if you remember that if you are adding the H plus and whatever conjugate acid you will get, that conjugate acid should be having the lower pK value, and such group will be better living group. So if you remember that pK values of various groups that we have discussed earlier, so this OR, when you are adding the R, it will become alcohol, and alcohol is having the pK value around 15, and these alkyl group will be having the pK value around 40. So lower the pK value, better is the living group. So this OR will depart. Okay, this OR will depart as you have added the H plus in the reaction. This OR, as it is departing, will take the proton and again it will form the alcohol. And when it is departing, oxygen will come to its original position. This negative charge will come to its original position. It will form a double bond, and you will get this component that is known as beta keto ester. Okay, so this is the mechanism for Dickmann reaction. So again I am repeating the mechanism for Dickmann reaction. You should be having the diester component, it should be having the it should be having the alpha hydrogen. So if you see the structure, this is the diester component, it is having the alpha hydrogen. When you are treating with the base, here we have used the alkoxide as a base, it will abstract the alpha proton and it will form the alcohol. And after giving the alpha proton, diester will have the inolate ion. Now this inolate ion will cyclize to form this structure, oxygen ion structure. Now this oxygen ion structure is having the OR. OR is the better living group, so it will depart and you will get the beta keto compound. Okay, so this is the mechanism for the Dickmann reaction. Here I have given two examples for the Dickmann condensation reaction. So again, first example, you can see that you are having the two ester functional group. Okay, you have added the alkoxide, you have added the acid catalyst. So again, in this case, alkoxide will abstract the alpha proton and it will form the inlet ion. Inlet ion will cyclize and it will lose its ethoxide ion and it will form this beta keto compound. Now you are having the second example. Again, in this case, you can see that you are having the two ester functional groups, so it will undergo the Dickmann reaction. You have added the this alkoxide, this sodium methoxide as a base catalyst. You have added the acid also. So now this alkoxide will attack the this alpha hydrogen to abstract that proton. Now this alkoxide will not take the proton from here. Okay, it will take the proton from this side, because here there is a methyl substituent, so here is more steric hindrance, so alkoxide cannot approach to this side of the ester to abstract the alpha proton. Here you are having the less substituent, so for alkoxide ion it will be easy to approach this side of ester and abstract the alpha proton from this carbon. So this side will form the inert ion, and then it will get cyclized, and you will get this beta keto ester compound.